Good afternoon, everybody. My name is Jude Cadet, and I currently work for Fiserv. And I'm going to be talking about geo-replicated databases for CRDTs. And I'm mostly going to speak from the platform perspective because I'm one of the engineers who helped kind of design and set up and deploy the first CRDBs over at Fiserv. So let me just go ahead and get started here. So just going to do a brief introduction, talk about Fiserv and how we use Redis in our environment. And then I'm going to talk about CRDBs from a Fiserv perspective, more so from the platform perspective. And then we'll go over some questions right after that. So starting out, who is Fiserv? Well, Fiserv is a global leader that specializes in payment processes. We're pretty much on the back end of banks and financial institutions. Those are most of our customers. We have approximately 12,000 clients in about 80 countries. Some of the things that we do that are probably a little bit more familiar to you guys is we are the back-end work for like Zelle and Pop Money. So whenever a bank is deciding to use one of those applications, that's actually us on the back end. We have about 24,000 employees worldwide. We're a Fortune 500. And last year, we pulled in about $5.82 billion in revenue for 2018. Some other things just to know about the company is that on Fortune's list, we are one of the world's most admired companies, and we've been that 6 years in a row. Also, those numbers as far as the amount of clients and the amount of employees, all of that is subject to change because I'm not sure if anybody heard, but we acquired First Data. So those numbers will probably change relatively shortly. If you'd like to know more about Fiserv and what we do, you can just go to the URL, www.fiserv.com and /about. And if you want to know about our standings and how we're doing on the Forbes Fortune 500 list, you can check out fortune.com/Fortune500 and Fiserv. So one of the things is how Redis has worked for us. We have primarily used Redis for two particular reasons, one for caching and one as a primary database. We have looked at using the open source version as well as the enterprise. And the open source version works pretty well, but it just doesn't have some enterprise grade tools that we need for security, redundance, failover. So we chose to go ahead and use the enterprise model because it's in line with our security and our redundant needs. For our cloud infrastructure, we are a Pivotal Cloud Foundry shop, and we are developing our own internal cloud. We're using Redis as the backend for that. For testing and development, we ask people to use the open source Redis that is packaged with Pivotal Cloud Foundry. But anything that is considered deemed with stronger importance or to be deployed in production, we are using Redis Enterprise. And we use it for caching, mostly for assessing state, for whenever we have people logging into some of our applications. It's just to cache their information, their login token, and then we're able to dispose of those sessions whenever we need to. Just more like temporary data. So currently we have about 27 clusters, and that's about 4 of them are allocated to Pivotal Cloud Foundry, our PCF implementation, and 3 of them are used as test lab clusters, but the rest are used in a relative production or a lab state. So one of the things is we had started off with using Redis 4.3 in our environment, and we've been using it for quite a while, and we've kind of watched Redis grow from 4.3 to its current state of 5.4 right now. And one of the things that we had noticed was when it comes to especially using it as a primary database, there was a need for being able to set up some sort of disaster recovery for those applications because they were imperative, and when we needed to have them up should anything happen in its primary site. So as we were using 4.3 and then moved up to 4.5, we also used 5.0. One of the big things that that really interested us was when 5.0. That's when they came out with the implementation of CRDBs and CRDTs. So one of the things is that that is only available in the enterprise version of Redis. So as far as we had other implementations where we would actually use some sort of failover. We just had an entire implementation of the application as well as a Redis cluster in our disaster recovery. And as far as to do a proper failover, we're either using a replica of, where we're dumping the data to another database in another Redis cluster, which really wasn't efficient. And suppose if we had to fail back over, we'd have to do the same thing back over. So it just wasn't an efficient way to fail over to a disaster recovery should we have an event happen. And when 5.0 came out, that's when we realized that probably the best thing to do is to go with an active setup using CRDBs. So what exactly is a CRDB? It's a conflict-free replicated database, and it takes advantage of the conflict-free data types that Redis has come up with, and it works in an active state. So it actually will sync the databases that are created in a CRDT fashion. It will sync them at all times, and so if there any changes happens on one side, it will definitely go ahead and make those changes and reflect it on the other side of the cluster. It doesn't matter where in the country or where in the world those two clusters reside. So why CRDBs? Well, we don't have to worry about any particular manual sync. We don't have to worry about replica of anymore. This allowed us to, if we have an event happen in one location, we can go ahead and just fail over to the other. And if we had to fail back over, it was seamless. So, that was some of the challenges that we encountered and why we decided to go with CRDBs once it was enabled in 5.0. And as far as for monitoring, Redis's REST API format is pretty decent. So we're able to use Splunk hooks to go ahead and pull and be able to tell us anytime events can happen. So, is there any questions so far? Okay. So now I'm just going to go over a bit about the Fiserv infrastructure and how we have it implemented in our environment. So this is just a basic topology just to give you an example of how we're using CRDBs. And let's see here. So as you can see, we've got the same application instance A running in Georgia in one of our data centers. And you have the cluster there. And you have a application instance over in Texas. And as you can see, there is replication going on between those two clusters. Now, with CRDBs, you have to remember that it's really basically about the database itself. So it's not the entire cluster is replicating across another entire cluster. It's just the database that you create on one side, it will create an instance on both sides, and they will replicate back and forth to each other. So that is our current state, our current setup, and kind of how we have things going. In the future, we actually are looking to work between three primary large data centers. So what we will do is we will probably have an implementation of a third cluster along with a third application instance. That way we can easily fail over in the case that there's an event in one or even both of the locations, that we will be able to have at least still another third location. So we're looking to implement that in our Arizona data center. That way we have a three-way failover possibility, and the application is always in sync. The databases are always in sync, and everybody's happy as long as it's up and running. Any questions so far? Now, as I mentioned earlier, CRDBs are just database specific and not really related to the cluster. So you have to go into your Redis cluster, and this setup is really from 5.0 and above. You will not see this in anything lower, and you will not see this if you are using the open source version of Redis. So this is actually snippets from the UI. You can actually create the CRDB by command line if you want to, but pretty much it's the same. So as you can see, you just go into the UI and you go to the database section, and you click on create new database, and it will pull up the first screen that you see right there. So you have to make sure you don't select single region and select geo-distributed, which will, once you hit next, you'll get the next screen over there. You make sure that you put your database name. You can set what memory limit you want for to allocate for the database. You could have replication enabled, which is local cluster replication, which means it will just go ahead and create another database instance within that cluster, and it will eat up a licensed shard, and it will put that database instance on another node. So if you have 3 or more nodes in your cluster on one side, you will have two shards for failover on that one cluster. Now, when you do that and it creates the CRDB on the other cluster as well, it's going to take 2 shards as well. So in a sense, that one database will be utilizing 4 shards. It'll have 4 instances, 2 for local replication and the other 2 for replication on the other side. Excuse me. So you can also enable persistence, which will write the data to disk, and that will just give you another form of redundancy. So you have an entire copy of the database written to disk, just in case you have any local issues, and that's local as well. So it will do the same. It will write it locally on a disk for the local cluster and the remote cluster. You will have to declare the endpoint. It will not randomly pick an endpoint the endpoint port number. It will not randomly pick an endpoint port number. So you will have to determine what port number you want to use for that database. And you have to keep in mind that I think it uses from port range from 10,000 to 19,999. So you have to stay within the allocated database port range that Redis has declared for it, but you have to determine which one it is. And then you can move from there. You can do database clustering if you want to. I think there was a workshop on database clustering yesterday, so I'm not going to go too deep into that. But when you're adding the participating clusters, first of all, they both have to be at least 5.0. And then it's probably best that you have them both the same version number. So if you have one cluster running 5.0, you want to make sure that the other is running 5.0. If you have the other running 5.2, the other side 5.2, and so forth. And then you will have to put the cluster 1 which is your local cluster that you're actually creating the database on. It doesn't really matter what order you do it, but you put the one that you're creating the database on, and then you put the remote cluster You have to declare the port number, otherwise it will not create the CRDB. So you have to declare that it is port 8080, and you have to put a username and a password that has access to the UI functions of the cluster or logging into the cluster. One thing that we did there was we realized that we kind of have like an admin operational login that we use. So what we chose to do was make a dedicated user just for the replication, because every time the replication occurs, it's going to use that login. So you might want to make a dedicated login for that function, and that way it will just take care of replication, and then you can have an administrative login just for other purposes. So, and once you hit activate, it will go ahead and create it. Any questions?
What is that casual consistency across replicas?
I'm not sure. I haven't looked into it, but you can look it up. I actually have a URL that has all about CRDBs and CRDTs as well, so I'll be sure to give that to you as well. All right. Anything else?
How about DB size changing on fly?
Excuse me?
Does CRDB support DB size changing?
Size changing on the fly?
Yeah.
I haven't done it. I've done it for non-CRDB databases, and it works flawlessly, pending that the current database is not larger than what you're trying. Like if you're trying to change the size to lower, if you're just trying to increase the size, I've done that for regular databases. I have not tested that with CRDBs. I assume it would be the same, but it's very possible it may not be.
One more question. So I see you use UI to configure CRDB cluster.
Yes.
Any command line tools or
Yes.
API tools do you have?
Yes, there is a command line version in which, when I first started setting up CRDBs, that was the first thing that I did, because I initially had some issues with using the UI. But I actually did not include that snippet with me right now. But there is a command line tool. I think it's one of the create commands. I don't know it off the top of my head, but you can do it.
Okay.
Are you looking to script it or something?
Yes,
Okay.
I'm looking for a way to automate CRDB deployment in cloud.
Okay. Yeah. You could definitely use it by command line and script it. It's not a problem at all. The syntax would be pretty long, to be honest, because you're adding all of the functions that you need. You're adding the endpoint port number. You're adding both clusters, so the syntax will be pretty long, but it's scriptable.
So last question. So I see you mentioned that DNS is required for CRDB. Can we avoid to use DNS to connect to clusters for CRDB?
Not for the enterprise version. You're definitely going to have to implement some sort of DNS structure, because the clusters themselves are using DNS.
Okay, it's point of failure. Okay, I think.
Yeah.
Okay, thank you so much.
All right, you're welcome. All right, so after we've created the CRDB, so just to kind of give you a view about how the data would move. So application A over here would go ahead and talk to the CRDB1 endpoint, the cluster endpoint on the first CRDB over here in Georgia, in cluster 1. So as it reads and it writes data, CRDB endpoint 1 will reach out to the node on cluster 2. And there is a process called the syncer. And that syncer is almost like a watchdog process. And I'll get into it a little bit more a little bit later. And that process will take notification that changes has happened on the database in cluster 1, and it will go ahead and talk to the endpoint on cluster 2, which will go ahead and make the changes over there. And vice versa. If you write any information over to application B, it will go from the application to cluster 2 to the syncer on cluster 1, and it will go ahead the application on instance A will be able to read that data, all the changes. Now, all of this typically happens in relatively 1 second, depending on your network latency. That's definitely going to make a difference. Geographic location, of course. But that's just the flow of how it all goes. I'm going to get a little bit more into how the syncer works. The syncer actually is actually just watching. It sits on the cluster, and wherever the primary shard for that CRDB is, that's where the syncer is running. So if you have the primary shard sitting on node 2 in your cluster, and it's a 3-node cluster, that's where the syncer is running. And vice versa, whatever node where the primary shard for the database is running on, same thing on cluster 2. So just to get you a little bit more familiar with the syncer, if you see, so it just monitors all changes, and it tells the other endpoint to go ahead and make those changes. It runs on one cluster and establishes a connection to an endpoint on the other cluster. So as you can see, I just ran a netstat and just grep for syncer, and it shows that on this current cluster, the syncer is running on that IP address, on that port number, and is connected to the other cluster on the other IP address using the endpoint, which using the database endpoint for whatever you set it as, which was, I set that for that database, that endpoint was set at 13,001. So, any questions about the syncer?
One second, sorry, sir.
Okay.
I need to bring the microphone to you.
Okay.
The application A or application B, does it read from other replicas of in the cluster? Or do you give only the one endpoint URL?
No. Application A, and let me step back up a bit to that picture to show you. So, application A is configured to read to one endpoint. So it will talk to the endpoint for the database in cluster 1. And application B is connected to the cluster B, to cluster 2. So they only talk to the clusters. The only place where syncing or communication between the clusters or between the databases happen is using the syncer between the clusters themselves. So if there's been a change on application A, the change will be committed to cluster 1. Cluster 1 will then sync to cluster 2, and then app B will be able to read those changes. And all of this happens in a few milliseconds.
But the traffic always goes to the master node, right? Because you're giving only the one endpoint URL.
Yes, if you are because you have one endpoint, the application will only talk to that one endpoint, which will talk to the master shard. So yes. And it's the same on the other side as well.
So when you use these systems, you have concrete ports and names. So I'm guessing you don't use Docker or Kubernetes or any of these systems?
Well, right now, we don't have a cloud implementation. We're working on our private cloud. And for that, we're using PCF. So, but we're not using Docker. Yeah. But even in that instance, we're using clusters. We're using enterprise clusters that are built. So when PCF goes and it deploys an application and it needs a Redis instance, it will use what is called the service broker. And the service broker is just a piece that was written by Redis to go out and talk to the Redis cluster, create the CRDB or database, whatever you need, and then it will say here's everything over to the PCF application that's requesting it. All right. Any other questions? Okay. So yeah, one of the things that we did was, so Redis was talking to us and they told us about all of this as 5.0 started to come out, and we decided to, well, you know, you say it's going to happen within a few milliseconds, you know, well, at least we were like, well, let's go ahead and just test it, just not only for us to see it, but to see how it would work across our environment. And so one of the things that I came up with was we wanted to try to get a timestamp of when exactly the data is pushed out from one application end, and try to pay attention to see how long it will take from when, like the diagram I showed, from app instance A to when it is reflected on the on cluster 2, which was over in Texas, and let's say app instance A is in Georgia. We wanted to see when it would reflect to the other cluster. So being a Linux guy, I decided to just use, you know, whatever I have at hand. So I used a couple of commands. I used time, and I used time to run a test application that I had that would just flood some junk data into the database, and just to kind of get a timestamp of exactly when it happens. And at the same time, I went ahead and set up a network capture on the database endpoint of the other cluster, because remember, in between, you've got from app instance A, which goes to cluster 1. Cluster 1 goes to the syncer, and on the other side, and the syncer talks to the endpoint, and then the endpoint commits the changes. So with all of that happening, I put the network capture on the other side of the database endpoint on the other cluster. So I just used TCP dump to kind of capture what was going on. And when I followed and watched the whole process, I noticed that it ended up being relatively, I forgot exactly how many milliseconds. I think it ended up being like about 6,800 milliseconds or something like that. But nonetheless, it was as advertised. It took less than a minute, and that was less than a second, and that was just going and monitoring the data syncs from Texas to Georgia with 2 different Redis clusters with a CRDB. So, do you have any questions?
Have you tried with more than 2 clusters to?
As of right now, no. When I tested with just 2 clusters, and that was because it was more so gearing up to what one of our business units wanted. So, but like I said, in the future, we're looking at implementing a 3 cluster setup, because we want to make sure that we have at least 3 major data centers, and that all the data, all the information when it comes to applications, resources, or whatever we're using, especially when it comes to key applications, that they're all able to run in each one of those data centers. So next up is to set up a 3 cluster CRDB.
Cool. Thank you.
From your grep command, it looked like the syncer was a separate process. So did you guys have any problem where syncer went down when the databases were up?
No, I've never had a problem with the syncer going down, at least not yet. So I'm not going to say it's not possible, but as far as my experience, it hasn't gotten down. It's been working great. It's never died or has gotten hung. So it hasn't had a problem.
So have you tested the high throughput between the two data center? Like what's the replication throughput, like a megabytes per second? What was in that perspective?
I didn't test the throughput, but from other tests between our Texas and our Georgia data center, I know we've had about, I think we run typically about 5 to 7K operations per second.
5-7K.
Yeah. But that's just on a regular basis. That wasn't checking with Redis particularly.
Have you what's the key value size? Do you mind to?
As far as when I did this test,
Yeah.
it wasn't anything big. Like I said, it was just an application that just flooded with junk data. So it was just a bunch of random bits.
Do you see any challenging from the replication throughput?
No, I haven't seen any particular challenges when it comes to throughput with our infrastructure. So the biggest issue was just to make sure that our network can handle it. We didn't have too much network latency or any network noise that would cause any kind of interference with it. So from previous tests from other things, that's why I figured with 5 to 7K we should be okay.
I see. Any network propagation latency?
Not with the CRDBs that I've tested and our production CRDBs as well.
I see. Thank you.
I do know when you use replica of, latency is a really big problem. So any hiccups, it can just totally wipe it out. So that's one thing that was great about CRDBs is that it doesn't pose that same problem that replica of does.
All right. Thank you so much.
All right.
Could you confirm this was not on PCF or was it on PCF?
This was outside of PCF. At least my testing was.
And
Yes.
you mentioned Splunk hooks for monitoring. Can you elaborate?
So Redis's API is pretty extensive. If you've downloaded and installed Redis Enterprise, the enterprise version, there is a full document in one of the directories. I can't really recall it off the top of my head, but your vendor rep should be able to tell you that directory in which it has everything about the APIs and all the API calls are available. So whatever you want to monitor, you can go ahead and just make those API calls from Splunk.
Which data types did you use?
There were, I didn't use lists. There were just general keys. I didn't specifically focus on the data types because I was more so focusing on the infrastructure part of it, how it runs, how it's set up. So I didn't dig too deep into utilizing different data types and things like that, because I wasn't looking at it from the application perspective. I was looking at it from the infrastructure perspective.
It's just that one, not necessarily problems, but
Yeah,
concerns that not all data types are conflict-free.
Yeah, and I'm not sure if you attended that session where they talked about the different data types and which ones. I think lists was one of the most complicated ones. So. All right. Well, if you have any more questions about CRDBs and CRDTs, you can go to redislabs.com. /S equals CRDT, and you can get more information about it. Feel free to ask me if there's anything I might not have covered, any pain points or anything that I may have experienced, and I'll be glad to answer any questions.
Thank you very much.